All right, average rate of change. This is kind of a fun topic in this class. It's still technically review. It's stuff that hopefully you've seen before. But it's going to turn out that it's really applicable to calculus, specifically Calculus 1. It builds on some of the topics that we reviewed in the previous section and takes us from there all the way to kind of the edge of calculus, where calculus kind of starts, in my opinion. Anyways, without further ado. In the previous review, we learned about functions. One of the many applications of functions is to model a real-world phenomena. So for example, maybe I'm going out for a hike and I want to keep track of my position. I want to keep track of how far I've hiked. I could model my position as a function of time. On the x-axis down here, I could track time. And on the y-axis up here, I could track my position. So I don't know, maybe these are hours and maybe these are miles. I could figure out how many miles I've walked after however many hours I'm interested in. So what a typical function question might look like is, how far do I travel in the first hour? And what's important here is that you can read this and kind of understand that you're being told the input to this function and you're being asked about the output. How far do I travel in the first hour? Well, I know that after 1 hour, my value of x would be equal to 1. So I'd be at this point up here on the graph where it looks like the value of y is equal to 6. So after 1 hour, I'm 6 miles into my hike. So how far do I travel in the first hour? I guess we should make sure that at time 0, we haven't gone anywhere at all, that we kind of start at the start. Maybe that's implied. After 0 time, we've traveled 0 miles. After 1 time, 1 hour, we've traveled 6 miles. So in the first hour, I've traveled 6 miles. If this function is f of x, where x represents time, the question, how far do I travel in the first hour, could be translated into figure out what f of 1 minus f of 0 is equal to. My position after 1 hour minus my position after 0 hours, 6 minus 0, I get 6. If it feels like I'm beating that to death and you're like, yeah, I get the point, that's good. I just really want you to be really comfortable with functions and inputs and outputs. And to test whether you're there yet, it'd be nice if you could read this next question and see what they're giving you here. How long does it take me to travel 12 miles? What about 18 miles? Are these the inputs that they're giving me and asking about the outputs? Or are these the outputs that they're giving me and asking about the inputs? If the previous section all went really well, you might be able to translate this into the output is 12 miles, figure out how long it takes, time is the x value, figure out what the x value is that would correspond to 12 miles. This question is asking you to solve f of x equals 12. As we saw in the previous video, to solve f of x equals 12, we just come up here to our y-axis and find 12, and then figure out where the graph attains a height of 12. Looks like that happens right here at the point 3, 12. So how long does it take me to travel 12 miles? That would just be the solution to this equation, and the solution to this equation is at x equals 3. It takes me 3 hours to go 12 miles. And I can do the exact same thing to figure out how long it takes me to travel 18 miles. Here's 18 up here on my y-axis. Looks like the graph attains a height of 18 way over here when x equals 7. The point 7, 18 is on my graph. Therefore, it takes me 7 hours to travel 18 miles. This question could be translated into solve f of x equals 18. And if I were solving that, I would get x equals 7 as my answer. So far, this has nothing to do with average rate of change. It's really just a review of the previous section where we're talking about functions. And I want you to understand that up here, I'm being told the input and asked for the output. And down here, I'm being told the outputs and asked for the input. If you got all that, we can move on to average rate of change. To kind of lead into average rate of change, I want to make an observation here. It kind of looks like I'm slowing down, which I guess makes sense if I'm out hiking. Right, in my first hour, I traveled 6 miles. I don't know that I could really do that. I don't hike that fast. But for the sake of this example, we can kind of assume that's the case. In the first hour, I was able to travel 6 miles. So this first little 6-mile span right here only took me 1 hour to complete. But to do the next 6 miles, to go from mile 6 to mile 12, that happened from time 1 to time 3. It looks like that took me 2 hours to do. And to get from the 12-mile point to the 18-mile point, that happened from the 3-hour mark to the 7-hour mark. Looks like that took me 4 hours to complete. So I did the first 6 miles in 1 hour, the next 6 miles took me 2 more hours, and then the next 6 miles took me 4 more hours. It looks like I'm slowing down here, right? This concept of slowing down, this idea of speed, is crucial to calculus. Sorry, my dog found a squeaking toy. Hopefully that won't go on for the whole video. Let me try asking you a question that we're not really equipped to answer right now. Am I walking faster 1 hour into my hike than I am 8 hours into my hike? I mean, based on the analysis that we've done so far, you might be like, yeah, definitely. And it sort of makes sense, right? I'm this old guy. I'm going to get tired the further I hike. After just an hour, I'm relatively fresh. I'm walking pretty quick. After 8 hours, I'm totally spent. I'm totally slowing down. And the data seem to support that, as it's taking me longer and longer to kind of accomplish these 6 mile sections. But I don't think that's enough to conclude that at this instant, 1 hour into my hike, I'm hiking faster than I am at this instant 8 hours into my hike, right? 1 hour into my hike, I'm at this point right here. 8 hours into my hike, I'm at this point right here. It looks like that point is 8,19, or at least really close to 8,19, as close as I can tell on this graph. All the evidence seems to suggest that I'm walking faster here than I am here, but how could you kind of prove that fact? How could you convince somebody that at this instant you're walking faster than this instant? Well, one idea, one strategy that you might employ is to think about your position 1 hour in, and then to think about your position a little bit after 1 hour in. And I know that that's not really concrete and that might bother you, but play along for a little bit. It looks like my axes are scaled here to break these hour intervals into 4 different sub-intervals. So let's look at a little past 1 hour into my hike, a fourth of the way to 2 hours into my hike. I guess this would be 1 hour and 15 minutes into my hike. In that 15 minutes, it looks like I went from 6 miles to 7 miles. So I walked almost a mile in that 15 minutes. That's a long way. Compare that with up here, 8 hours into my hike. If I look at 15 minutes after this point, I'm at this point up here on my graph. I can't tell exactly what the y coordinate is here when the x coordinate is 8 1/4 or 8 hours and 15 minutes into my hike, but it's pretty damn close to 19, right? In this 15-minute span, I'm barely covering any distance at all. The distance that I cover is just the difference in the heights of these 2 orange lines. It's a lot less than the distance between these 2 pink lines. It's a lot less than a mile here. That's further evidence that I'm walking slower 8 hours into my hike than I am 1 hour into my hike. And maybe you're like, yeah, I get the point. You're walking slower 8 hours into your hike. Move along. And here's where I'd caution you to be really careful. We haven't proved that we're walking slower 8 hours into our hike than we are 1 hour into our hike. All we've shown is that we cover less ground from the 8 hour to the 8 hour and 15 minute mark than we do from the 1 hour to the 1 hour and 15 minute mark. But think about how that could happen. Maybe at the 8 hour mark, I'm walking really fast for a split second. And then I slow down for the rest of that 15-minute interval. And maybe at the 1 hour mark, I'm walking really slowly and then I speed up for the rest of that 15-minute interval. So that in this 15-minute interval, I end up covering a lot more ground than I do in this 15-minute interval. Sorry, I gotta take this chew toy away from my dog. This is driving me crazy. Anyways, the point that I'm trying to make, and maybe I'm making it more confusingly than I need to, is instantaneous speed is really, really complicated in math. In fact, there's an entire class, Calculus 1, devoted to this idea of instantaneous speed. And in these videos, as we learn about average rate of change, we'll kind of scratch the surface of that topic. And if this example that I'm going through right now makes any sense to you, if you're able to follow how it's really difficult to conclude that I'm walking faster 1 hour into my hike than I am 8 hours into my hike, just based on the tools we have, then you're following everything perfectly. By the way, I am walking faster 1 hour into my hike than I am 8 hours into my hike. And I can tell that just based on this graph. And kind of spoiler alert, the way we'll end up doing it is we'll sort of look at the graph right here and consider how steep this curve is. And compare that to the steepness of the curve over here 8 hours into my hike. Even without knowing how to calculate it or really define it, I think we could agree looking at this curve that it's steepest down here and it slowly gets less and less and less steep the further we go. And you're like, oh yeah, steepness. I can totally talk about that. I learned all about slope in the previous videos. Yeah, you did, but you learned about the slope of lines, not the slope of curves. Slope is not a term that's defined for curves, and that's going to be the crux of calculus. That's what we're going to have to get into in these videos. So to answer this question and end this video, am I walking faster 1 hour into my hike than I am 8 hours into my hike? Absolutely. We certainly are. Unfortunately, we don't really know how to prove that we are just yet. But I can tell you, as someone who's taught calculus many, many times, that we'll be able to prove that fact soon. And really what it comes down to is the observation that, loosely speaking, the curve is steeper over here at 1 than it is over here at 8.